If milky white precipitate is formed, it confirms that the given organic compound is having a carbon. That sodium fusion extract will be used for the different detection of elements. The formation of black color precipitate is due to the lead sulfate, which indicates that your organic compound is containing a sulfur. The nitrogen can be estimated by the two methods. One is Dumas method and the one is Dumas method. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with a unit called Organic Chemistry, some basic principles and techniques. Under this unit, we have studied about how the methods will be followed for the purification of the organic compounds. Under that, we have studied about the sublimation, crystallization, distillation and chromatography. Today, we are going to understand what is meant by the qualitative and the quantitative analysis of the organic compounds. Okay, I'll go with a qualitative analysis of organic compound. So, this quality of the organic compounds which tells about how we are going to analyze the given organic compound that contains carbon, hydrogen. In addition to this, if any nitrogen is there, sulfur is there or phosphorus is there or if any halogen is there. So, which are the methods that we are going to select it for that and how we are going to analyze it, that we are going to study in the qualitative analysis of organic compound. So, the elements present in the organic compounds are carbon, hydrogen. In addition to this, they also contains what? Oxygen, nitrogen, sulfur, halogen and phosphorus. I will go with the detection of carbon and hydrogen from the given organic compound. Okay. So, this is the first thing that you must know, that how the methods will be done and how the entire process will be done for the detection. Okay. The carbon and hydrogen is detected by heating the compound with the copper 2 oxide, which we also call it as what? Cuprous oxide. The carbon present in the given organic compound is oxidized to carbon dioxide and the hydrogen is oxidized to water. So, which is tested by anhydrous copper sulfate and the carbon dioxide is tested with the lime water, which turns into milky. Let us understand with the reaction now. So, now you have organic compounds which are containing what? Carbon. If it is react with the cuprous oxide, what does it forms? It forms carbon dioxide as well as it liberates copper. Okay. So, this is a thing that you must know it. Suppose if the hydrogen is there in your given organic compound, it will be heated with cuprous oxide, it forms H2O, okay, and leaves the copper. So, this indicates that whatever the carbon and hydrogen is there in the given organic compound, if you allow to react with the cuprous oxide, that is copper 2 oxide, it forms a carbon dioxide and a water respectively. But we need to confirm that how the carbon dioxide and the water molecule has been formed. Correct, no? So, that is why we allow this carbon dioxide to react with the lime water. So, lime water is nothing but calcium. Correct. And thus calcium. Lime water is nothing but calcium hydroxide. It forms CaCO3, that is a milky white precipitate. Okay. Then it liberates water also. It liberates the water molecule. This confirms that if milky white precipitate is formed, it confirms that the given organic compound is having a carbon. Similarly, the vapors of the water will be allowed to react with anhydrous copper sulfate. Anhydrous copper sulfate, what does it form? It forms copper sulfate pentahydrate will be formed. Copper sulfate pentahydrate will be formed. This is hydrated copper sulfate which confirm that water molecule is there in the given organic compound. This is how the carbon and hydrogen, if it is there in the given organic compound, can be detected by using copper oxide method or with the copper to oxide method. Now, and hydrogen is over, but we need to detect with the other elements which is there in the given organic compound, correct? So, that is why we will go with the detection of other elements such as nitrogen, sulfur, phosphorus and halogen present in the given organic compound just by preparing lessons, reagent and the test we call it as what? Lessons test. What does mean by Lessons test? Let us understand now. So, for this Lessons reagent preparation or with the sodium fusion extract, we are going to select a small amount of, so we are going to select a fusion tube. It is a long tube and it is very thin. We are going to place a small amount of sodium in this fusion tube. This is a fusion tube. Okay, we are going to place what? Sodium, and we started heating. When we started heating, the sodium will be melted in the fusion tube. Afterwards, we are going to add the organic compound for this. Now, we are going to heat this mixture until unless this entire fusion tube should become what? Red hot. Okay, so it should become what? Red hot. Then this fusion tube should be transferred to the china dish which is already containing 5 to 10 ml of water. 5 to 10 ml of water, and we are going to drop out this fusion tube into this china dish and we are going to crush it by using a china dish mortar. Then we are going to filtrate it and you are going to get, we are going to filtrate it and we are going to get the pure solution. Okay. This solution we call it as what? A sodium fusion extract. That solution we call it as what? Sodium fusion extract. That sodium fusion extract will be used for the different detection of elements. Okay. Now, I will go with the test for nitrogen. How they will do? Let us understand. The sodium fusion extract will be boiled with ferrous sulfate, then acidified with concentrated H2SO4, then formation of Persian blue color which confirm that the presence of nitrogen. So, you are taking sodium fusion extract and you are going to add the ferrous sulfate for this mixture and you are going to boil it. Then you are going to add a concentrated H2SO4 for this mixture. The formation of a Persian blue color which confirm that nitrogen is there in the given organic compound. Next is detection of sulfur. The sodium fusion extract is acidified with acetic acid and lead acetate and added to it a black color precipitate which indicates that it is a sulfur which forms a lead sulfate and indicates the presence of sulfur. So, how does the reaction will look? So, here you are going to take the sodium fusion extract and you are going to add the lead acetate, correct? Lead acetate, then you are going to add acetic acid, lead acetate. So, the formation of, lead sulfate, this is a black color precipitate. The formation of black color precipitate is due to the lead sulfate which indicates that your organic compound is containing a sulfur. Next is test for the halogen. So, here the sodium fusion extract we will take and we will treat it with nitric acid, okay, nitric acid, and in presence of silver nitrate, if you started heating, you know, if you got a silver chloride, okay, which gives a white color precipitate, which is soluble in ammonium hydroxide, then it indicates that your chlorine is present in the given organic support. Suppose if it is forms a silver bromide, it is a pale yellow color precipitate. So it is sparingly soluble in ammonium hydroxide. Okay, it is sparingly soluble. Sparingly soluble. Then we say it is, suppose you have a dark yellow color precipitate which is due to the silver iodide. So if you get a silver iodide which is a dark yellow precipitate, if it is get completely insoluble in ammonium hydroxide, we say it is a given organic compound which containing what? Iodine. Like this, the formation of silver iodide, the formation of silver bromide and formation of the silver chloride, which indicates that which halogen it is. And remember the color also. If it is chlorine, we get a white precipitate. If it is iodine, we get a dark yellow precipitate. If it is a bromine, we will get a light yellow precipitate, and all this precipitate which is allowed to dissolve it in a ammonium hydroxide. So you will come to know that which precipitate is going to dissolve it, or which precipitate is going to be insoluble, or which precipitate is going to be sparingly soluble. Like this, the detection of halogen, which is also done by using sodium fusion extract. Okay. Next we have a detection of phosphorus. The given organic compound containing phosphorus is heated with sodium peroxide, which is an oxidizing agent which oxidizes the phosphorus into phosphate, and the solution will be boiled with nitric acid, then treated with ammonium molybdate. The presence of yellow coloration which indicates that it is a phosphorus. Okay. Next we have the quantitative analysis. Now you know that how to say in terms of detection of different organic compounds which are containing carbon, hydrogen, nitrogen, sulfur and phosphorus in terms of a qualitative. Now we have to say that what is the percentage of each element which has been present in the given organic compound. That is why we are going with a quantitative analysis. So let us see how they will do here. The percentage composition of the element present in the given organic compound is determined by a different method based upon the following principle. The first one is estimation of carbon and hydrogen by Liebig's method. Okay. So here the known quantity of given organic compound is heated with a cupric oxide in the atmospheric air and oxygen which has been free from carbon dioxide. The carbon and hydrogen present in the given organic compound will be get oxidized to produce what? Carbon dioxide and water respectively, as we have already learned. The carbon dioxide will be produced is collected with a potassium bulb, whereas the vapors will be absorbed in anhydrous calcium chloride tubes. From the amount of carbon dioxide and water vapor which is produced, the percentage of the carbon and hydrogen will be calculated. So this is a formula, but you will come to know by looking at with the apparatus. So this is a long tube and we have a boat shaped platinum. In this we are going to put a given organic compound, and we have put the cupric oxide also. We have added the organic compound with cupric oxide and we have started heating. When we started heating, this entire mixtures which is going to form carbon dioxide and water respectively. This water will be get absorbed, by the calcium chloride, whereas carbon dioxide will get absorbed in the potassium hydroxide solution. So how they will do the detection here? Let us consider the mass of this given organic compound as m gram. Okay, but the mass of the water as a 1 gram, whereas the mass of carbon dioxide as m2 gram. Now I know that from the stoichiometric equation, the percentage of the carbon is calculated by this equation, that is, what is the molecular mass of carbon dioxide? So it is 44 gram. So 44 grams of carbon dioxide contains how many grams of carbon? 12 grams of carbon. Correct? 12 grams of carbon. So that is why I will consider the M2. Correct? So M2 grams of carbon dioxide contains how many grams of carbon? Look at the equation now. The percentage of the carbon can be calculated 12 divided by 44, because you will get this cross multiplication equation, 12 divided by 44 into M2. Okay. So 12 divided by 44 into M2 into 100 divided by M1. M2 is a what? It's a molecular mass of the carbon dioxide, where M is a molecular mass of the given organic compound, or it is a mass of the given organic compound. Similarly, you know, in water molecule, what is the molecular mass of the water molecule? It is only 18. So 18 grams of water contains how many grams of hydrogen? So there are 2 hydrogen will be 2 grams of hydrogen. Similarly, M1 grams of water contains how much grams of hydrogen? So just it is a cross multiplication. So it is 2 divided by 18 into M1. Correct now? So it is 2 divided by 18 into M1 divided by into 100 divided by M. So M1 is a molecular mass of the water and M is a mass of the given organic compound. This is how they will do the estimation. Next we have estimation of nitrogen. The nitrogen can be estimated by the 2 methods. One is Dumas method and the one is Geldar's method. Let us understand with the Dumas method first. So in this method, a known weight of organic compound we will take, which we strongly heated with the cupric oxide. The carbon and hydrogen will be first get oxidized to give carbon dioxide and water vapor respectively. Nitrogen if present, it is converted into nitrogen gas and collected over the potassium hydroxide solution, and the volume will be determined by STP condition, that is the standard temperature and pressure. This is the equation, delta equation I have shown that how does the given organic compound, if you heat it with a known amount of cupric oxide, it liberates X volumes of carbon dioxide and Y by 2 grams of volumes of water, and also it liberates the nitrogen gas. Now how to derive the equation? So we have to find out that the given organic compound you have heated with cuprous oxide and you got a nitrogen gas. So the volume of this nitrogen gas at STP you need to calculate it, correct? At STP. So let the mass of the organic compound will be m gram and the volume of the nitrogen collected as V1 gram at room temperature. So we get an equation that is T1 Kp1, which is equal to atmospheric pressure minus aqueous tension. Okay. So at STP, molar volume will be usually equal to 22,400 milliliters of nitrogen, which contains how many nitrogen? 28 grams of nitrogen. So that volume of the nitrogen at STP will become P1V1 into 273 divided by 760 into T1. So or you can write this equation just by taking the ideal equation also. Ideal equation, what does it give? That is P1V1 divided by T1 will be equal to P2V2 divided by T2. So this is the temperature, pressure and volume at STP, and this is at with the other condition. Okay. Now as I told you, we need to calculate the volume of the nitrogen gas at STP. Correct? At STP. So if you taken outside, so it will become a cross multiplication P2V2 into T1 divided by P1 into T2. So we know that the pressure at STP is 760, correct? Of Hg into T2 divided by P1V1 V2 P2V2 into T1, how much? It is 273, correct? So this is how we will calculate the volume of nitrogen gas at STP, correct? So this is the equation I have written. Now if I want to calculate the volume of nitrogen gas which is liberated at STP, I'll multiply it with the molar volume of nitrogen gas, which contains this much amount of nitrogen divided by this is the molar volume into volume of nitrogen gas at STP. We can calculate it by this equation into 100 divided by mass of the organic compound which has been taken. Next is estimation of halogen. So again, the estimation of the halogen will be done by K-12 method. So in this known mass of organic compound or known weight of organic compound, we are going to heat it with fuming nitric acid. Then we are going to treat with the silver nitrate in a hard glass tube. Hence it is known as what? K-12 tube. After when you treat it, if carbon and hydrogen is there in the given organic compound, can oxidize to carbon dioxide and water respectively. If halogen is there, so it will form a silver halide. Suppose imagine you have an organic compound treated with fuming nitric acid, that is HNO3, in presence of silver nitrate, it forms what? Silver halide. Okay, and we will come to know that what is that silver halide is, whether it is chlorine, bromine and iodine with a different precipitation. Okay. Later it will be filtrated and washed and dried and weighted. Let us consider the mass of this organic compound will be x gram, or you can take it as n gram also, and mass of the silver halide which is formed as m1 gram. Now 1 mole of silver halide contains 1 mole of halogen. The mass of the halogen will be obtained by atomic mass of the halogen into m1 gram divided by molecular mass of the silver halide. Let us see with an percentage of the halogen with the actual formula, that is atomic mass of the halogen divided by molecular weight of the halogen halide into weight of the halogen halide divided by weight of the organic compound into 1000. Suppose if the chlorine is there in the given organic compound, the weight of the atomic weight of the chlorine is 35.5 and the molecular weight of the silver chloride is 143.5 into weight of the silver chloride which is formed divided by weight of the organic compound into 100. Suppose if a bromine is there, atomic weight of the bromine is 80 and the molecular weight of the silver bromide is 188 into weight of the silver bromide formed divided by weight of the organic compound into 1000. Suppose if your organic compound is iodine, the atomic weight of the iodine is 127 and the molecular weight of the silver iodide is 235 into weight of the silver iodide formed divided by weight of the organic compound into 100. This is how for the different detection of halogen like chlorine, bromine and iodine can be estimated by using K-12 method. Next we have estimation of sulfur. A known weight of organic compounds which are containing sulfur, which has been heated with a sodium peroxide or HNO3 in K-12 tube. The sulfur is oxidized to sulfuric acid. Then the precipitate will be having barium sulfate that you will get after treating with the barium chloride. I can show this with the equation. So you are taking an organic compound, imagine, okay, which you are heated with fuming nitric acid, and whatever the sulfur is there in the given organic compound will be converted into sulfuric acid. Later the sulfuric acid treated with barium chloride. So you got what? A barium combines with the sulfate as barium sulfate and you got a HCl, correct? So HCl is a gas which has been formed. By knowing the mass of this barium sulfate, okay, which containing this much percentage of the sulfur, we can easily calculate the percentage of the sulfur. So now I will consider the mass of the organic compound as m gram, okay, and the mass of the barium sulfate which is formed as m1 gram. So how to derive this equation? I have to get the molecular mass of the barium sulfate, which is nothing but 233. So you can write the stoichiometric equation. 233 grams of a barium sulfate contains how much of the sulfur? 32 grams of sulfur, correct? So now m1 grams of BaSO4 contains how much of sulfur? Just do the cross multiplication. It is 32 divided by 233 into m1, correct? So you will get the percentage of the sulfur as 32 into m1 into 100 divided by 233 into m. m1 is nothing but the mass of barium sulfate which is formed divided by mass of the given organic compound. Okay. Next, estimation of phosphorus. The known mass of organic compound is heated with the fuming nitric acid. The phosphorus will get oxidized to phosphoric acid. Ammonia and ammonium molybdate and phosphoric acids are precipitated as ammonium phosphomolybdate. Then it is filtered and dried and washed. From the weight of ammonium phosphomolybdate, as I showed with the earlier case, we are going to estimate the percentage of the phosphorus. So here the molecular mass of the phosphorus is 1877 gram. Then the mass of the organic compound will be m gram and the mass of the ammonium phosphate will be m1 gram. So just divide this much quantity of ammonium phosphomolybdate which contains how many grams of phosphorus? 31 grams of phosphorus. So 31 divided by 1877 into m1 into 100 divided by m1. What is m1 here? It is the mass of the organic compounds which are containing ammonium phosphomolybdate and m is nothing but mass of the organic compound. Just by using this percentage formula, we are going to calculate how much of percentage of the phosphorus which is also there. So this is all about the organic chemistry, some basic principles and techniques which has been a basic principle which has been kept, or the basic concept which has been kept in this unit. Try to understand this unit. Wherever you are not understanding, pause the video and make it understand. Okay. Hope you all understood with this unit. I'll come back to the next unit. Till that, take care and be safe. Thank you.